See this question, which of the following is false? So we are supposed to find out of these four options which one is false. So see this one, if R1 is a relation, okay, if R1 is reflexive, then every superset of R1 is reflexive. So they are saying that if a relation is already reflexive, what can you say if we add more elements to that? See this, if R1 is reflexive, then every superset, so what is it they are asking? Already R1 is reflexive and they are trying to add more elements to that, then only we are going to get superset, isn't it? Then every superset of R1 is reflexive. What do you say? Let us say if we have A equal to 1, 2, 3, then when will R1 be reflexive? If R1 has to be reflexive, it has to at least contain 1, 1, 2, 2, 3, 3. I am not saying that it is definitely 1, 1, 2, 2, 3, 3. It has to at least contain this. Apart from this, there might be other elements as well. We don't care. But definitely these three will be present. In case if A equal to 1, 2, 3 and if R1 is a relation on A, then R1 will be reflexive only if it contains these three elements, and apart from this it can contain many elements also, right? Now they are saying that to such a relation, we don't know whether others are present or not, to such a relation R1, if I add more elements, okay, from A cross A only, even though they didn't mention that they are adding more elements from A cross A, you have to think that they are adding the more elements from the same set where R1 is formed, okay. So even if we add more elements, more ordered pairs from A cross A, what do you say? So even if we add more elements, still it is going to be reflexive because it is going to contain 1, 1, 2, 2, 3, 3, the diagonal elements. Therefore this one is true, isn't it? That one is true. Okay, if I tick it, you might think that it is false. Let me write here, this one is definitely true. Now let's see about option B. If R1 is reflexive, then every subset of R1 is reflexive. Think about it. Let us take the same example. See, most of the cases whenever such a question is asked, it is always better that you take an example like this and visualize it. That way you will be able to answer it better, okay. Visualization will work here. Now let us say this is R1, 1, 1, 2, 2, 3, 3, that is the smallest reflexive set. I can assume anything, right? Because since they are saying that R1 is reflexive, I'll assume that R1 is the smallest reflexive relation possible, which is 1, 1, 2, 2, 3, 3. Now every subset of R1, so I'll take a subset of this. Let us say a subset is 1, 1, isn't it? Then they are saying that every subset, that is what they are saying, every subset is reflexive, but then this is not reflexive, right? Why? Because it should contain all the diagonal elements. It is not containing all the diagonal elements, it is containing only one diagonal element. Therefore the B is false. So we got the answer. So which of the following is false? B is false. Still we continue further and we shall see the next two also. Let us say they are saying that R1 and R2 are reflexive, then what do you think about R1 intersection R2? That is what they are asking. If R1 is reflexive, we know that it will definitely contain diagonal elements. Along with that, it may contain other elements, right? And now R2, if R2 is also reflexive, that is what they are saying, R1 and R2 are reflexive, therefore R2 should also contain diagonal elements 1, 1, 2, 2, 3, 3, and along with this it may contain other elements as well, may or may not. Now they are talking about R1 intersection R2. When we take R1 intersection R2, then definitely these three are going to be present in the intersection, isn't it? Why? Because these three elements, the diagonal elements, are present in R1 and they are present in R2 as well. Since the diagonal elements are present in both of the sets, they will be present in R1 intersection R2. Therefore the set R1 intersection R2, the relation R1 intersection R2 is definitely going to be reflexive. It is true, right? Now R1, R2, if they are reflexive, then R1 union R2 is reflexive. Think about it. R1, R2 are reflexive, then R1 union R2 is reflexive. How can we justify that? So if you think of it in other terms, R1 is already reflexive, and what can you say about R1 union R2? R1 union R2 is definitely a superset of R1. Think about it. We are going to get R1 union R2 from R1 by adding some elements to it. Therefore, R1 union R2 is definitely a superset of this. We already know that if a set is reflexive, if a relation is reflexive, then its superset is reflexive, isn't it? Therefore, what can we say about it? It is reflexive, true. I hope you are understanding this. There are two ways to think about it. If R1 is reflexive, I don't care about R2. R1 union R2 is going to be reflexive because it is going to be a superset, and we know that every superset of a reflexive relation is going to be reflexive. Using that law, I can say that it is reflexive, isn't it? But then one other way of doing it is R1 and R2 both are reflexive, right? Which means both are going to contain all the diagonal elements. If I take the union of these two, again the result is going to contain all the diagonal elements, and so we can say that it is reflexive, right? So this kind of questions can be possible on this. Some other kind of questions will be this. See here. Even this can be extended like this. If R1 is reflexive, I don't know about R2. What can you say about R1 union R2? I am not saying that R2 is reflexive. So since R1 is going to contain diagonal elements, R1 union R2 will also contain diagonal elements, because all the elements of R1 will automatically come into R1 union R2. Therefore, we can say that it is reflexive because it is simply a superset, isn't it? Now, let us say R1 is reflexive, and I am not saying about R2. What can you say about R1 intersection R2? Is it reflexive? Now it depends. Without knowing about R2, we cannot answer this question, because if R2 is not reflexive, right, then the intersection may not be reflexive. So if R2 is reflexive, see, are you understanding this? If R1 is reflexive and R2, I am not talking about it, I am not giving you anything about R2, no information is given, then what can you say about R1 intersection R2? Then R1 intersection R2 may or may not be reflexive. Why? Because if R2 is reflexive, then both R1 and R2 will contain diagonal elements, all the diagonal elements, and so R1 intersection R2 will contain all the diagonal elements, and so it is going to be reflexive. Therefore, if R2 is reflexive, then R1 intersection R2 is going to be reflexive, right? Otherwise, what is the other case? If R2 is not reflexive, if R2 is not reflexive, then what happens is, what does it mean if R2 is not reflexive? Means R2 doesn't contain all the diagonal elements. Therefore, definitely the intersection will not contain all the diagonal elements. Then we can say that this R1 intersection R2 is not reflexive, right? So if you are not able to guess it like this, always take an example and try to evaluate it, okay? Whenever they are asking, saying that it is definitely reflexive, right, it is always reflexive, something like that, it is better you take an example and work it out. So I have given you only few examples. There can be many other questions possible like this: R1 intersection R2, R1 union R2, something like this. Then take the example and then try to work it out. At least take 2-3 cases, then you will be clear about it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.